Hey guys, welcome to my channel. I was on Twitter the other day and I saw this.
Testing. Yeah, I made a face mask that lights up. I don't know if I'm actually gonna wearing it because it kind of requires you carrying around this in your pocket.
Yes, this is a face mask that reacts to the voice of the person wearing it. So how cool is this? I was like, F yeah, I love LEDs. I know, it's 2021 and you're expected to wear fancy pants or eyeglasses all day, but this is all we got. So I decided to build my own sound reactive LED face mask. Obviously I need a proper mask to cover all my mouth and my nose, and it has to be washable. So a takeout of all the electronic components has to be possible, because I will not design washable electronics, if this is even possible. Well, not for me today, so let's go on. Obviously I have to fit all the LEDs inside the mask, and I have to make a diffusion layer so that the lights are all nicely diffused and they are not directly attached, because normally LED lights can be really bright and will hurt your eyes. So diffusion is a must for LED project. And yeah, of course, we have to make the mask. So with all the requirements set, we are ready to go. Let's build the mask. The mask is actually the easy part. All you do is this. You have this piece of paper and you fold it 2 times, one time and another time. And then all you do is, and done. Easy as that. Well, yes, YouTube magic, I know. So I didn't actually make this mask myself. A friend of mine made it for me, because I'm not good at stitching. So maybe I can stitch my jeans if I have a little hole in it, but I cannot stitch a whole mask and I don't have the equipment here. So a friend of mine helped me out and stitched this whole mask for me. So thank you, Lindy. Love ya! If you're interested in making this mask, I will link the layout, the plan for it, so you can make it yourself in the link down in the description. Yeah. Yeah. So this mask is perfect for this project because it has 2 walls. So as you can see, it's double layered, so I can fit all the electronics inside. Perfect. I'm so excited to put LEDs in here. So let's start. So first, electronics. As a base I will use a fan filter, as I have to breathe through it, a solid piece won't cut it. Also it's nice and flexible, so it can nicely fit my mouth and nose area. Also look at this weird effect.
Toby, what are you doing?
Next we need LEDs. I used the WS2812B. These strips are really bright and individually addressable. This means I can control each pixel and set them to the color I like. And I like colors. Also they run on 5 volt, which means I can power the whole thing with a battery bank and I don't have to build my own battery pack, which is pretty neat. Next to the microcontroller, I have a wide range of microcontrollers available to me. I could use a Raspberry Pi B3 Plus because it's right here and because it's a very powerful board, which is 4 1.4 GHz cores, but as you might agree, it's a bit chonky. The next choice could be an ESP32. This chip is a lot smaller, but still has 2 cores running at 240 MHz. But again, having a real-time operation system is nice, but not needed for the project. Which brings me to the last choice, the WeMos D1 Mini, which only has 1 core running at 80 MHz, but it's tiny and it has enough power to run my code. And it's still much more powerful than an Arduino. I could use the bare bones ESP8266, which the WeMos D1 Mini is based off, but it has no USB ports, so I have to use a special programmer, which I don't have. The ESP8266 also has built-in Wi-Fi, which is pretty nice to have, but technically, yeah, you're right, I don't need Wi-Fi for this project, but better have than miss, right? The ESP will run the LEDs just fine, and with its 2 MB of flash I can store plenty of animations, if I want to program any. Spoiler, I don't. But anyway, as a microphone I use the MIX4466. It's cheap, it has a good sensitivity and it can be adjusted. It also runs on 5 volts, which is perfect. Let's build it. I started with measuring the side entry of the face mask with a caliper and used its sharp edges to directly mark the mesh of the fan filter, which yielded a nice vertical line. I used this line to cut the filter in the right shape. Also, I rounded the corners so I can slide the fan filter easier into the mask. Next, I laid the LED string on top of the fan filter base to roughly measure the LED count I need. Then I cut the LED strip, which is easily cuttable at the marked spots, and counted the number of strips I need. I decided on 4 LED strips. All the strips have an adhesive backing, which is covered by a protective tape. You can peel it off using your hands or an extractor knife. I placed the strips on the base so that all the LEDs have the same horizontal and vertical spacing, which is very important for the correct displaying of the animations. Also pay close attention to the orientation of the LED strips. As you can see, I have aligned the strips in a zigzag layout. Then I primed the copper-plated contacts of the LED strip, which solder so I can add the wires easier. I added the data wires first. The signals come in from the top right and then zigzags its way down, as you can see here. Next, I joined all the 5 volt lines from one side together using a red wire. After this, I repeated the step with the ground wire on the other side. Pay close attention to the wires not touching each other, because a short can kill your LEDs. Next, I had to figure out where to place the microcontroller. Not in front of course, but top and down are also out of the race. I figured right next to the LEDs would be just fine, as I could easily access the USB port of the WeMos D1 Mini this way. I cut the connector off and soldered the connections directly to the strip to save space. I double checked all the connections for a potential short and got my trusty power bank with output current display. I plugged the USB in and hoped for the best. Whoa, that's really bright. I had to turn down the brightness to around 20%, which is still plenty. On 20% brightness, the strip only consumes around 0.3 amps, which is in total 1.5 watts. So even a tiny battery should give you hours of battery life. Lastly, I added the microphone. I just soldered the red wire to 5 volts, the grey wire to ground and the green wire to A0. The analog input pin of the ESP. As a finishing touch, I decided to add hot glue to protect the solder spots and keep it all together. As you can see, the finished LED insert is quite flexible. And all you have to do is to gently put it in. I know, that's what she said. Let's get over with it. As it is built now, it's time for the code. And I know the YouTube algorithm a bit, so as soon as I show you one line of code, the vast majority of you will just disappear. So I will make this short. The ESP reads the microphone analog output values and calls some custom animation depending on the output intensity. That's it. If you, against all odds, have interest in the code, check out my GitHub in the link below. So, it's done now, I can't wait to try it on. So, here we go! Hey! So, how does it look? Well, I guess I have to check in the mirror. So, there we have it, guys. This is it, the final version. And I think it came out quite good. Look at this. Oh, 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 oh. That's quite good. I even can like... Hey. I like it. It turned out quite good. But I have one last thing. As I told you earlier, this chip has built-in Wi-Fi, so I might well use it. I downloaded WLED, very great wireless LED library for controlling multiple LEDs via an ESP. I flash it onto the chip and give it a spin. Thank you guys for watching. I hope you enjoyed this one. And as you may see, I'm completely new to YouTube. So consider subscribing if you want to see more cool projects like this one here. And in the end cut I have some nice shots of WLED and this mask. Enjoy and see you in the next one.